Hello students, welcome to section 6.2 continued. Example 3. A port is 50 miles due north of a lighthouse. A ship is 30 miles at a bearing of 37 degrees east of north from the lighthouse. How far is the ship from the port? Now I've already denoted here side angle side, but we're going to talk about why that's the case. As we can see here, hopefully our picture takes shape. So with regards to the picture, we'll start with point C at the port. We'll start with point B where the ship is, and then point A I'm denoting as the lighthouse point. So as you can see, again, 50 miles due north from lighthouse to port. Due north is literally just above, again, north, south, east, and west, just above point A. So 50 miles, as you can see, denoted as such. And I called that side B because it's opposite angle B. Again, point B is where the ship is, and it does denote technically, again, that the ship is 30 miles at a bearing of 37 degrees east of north from the lighthouse. So the point of which A, 37 degrees, there it is, east, so going in this direction but north. From point A to point B, lighthouse to ship, we've denoted side C. Again, side C is opposite angle C, and this of course is 30 miles. So it shouldn't be a big surprise that we have side, angle, side. So in the context of finding how far the ship is from the port, we've got from C to B as segment A or side A. We'll use the law of cosines. Law of cosines for this particular problem, if I'm finding A in context, it's as you can see, B squared plus C squared minus 2 times B times C times cosine of the included angle 37 degrees. So if we do that math, and yes, on your calculator, of course, you'll be able to see this. And I will ask, though, that you also take the square root of that decimal. It turns out, when doing so, you'll end up with the following. So typing this in, square rooting both sides, 31.69 miles. Okay, next, if you take a look at Heron's formula, derived from a proof of the law of cosines is Heron's area formula, which is the following. Area of a triangle is equal to the square root of s times s minus a times s minus b times s minus c, where s is equal to the sum of the three sides over 2. So there is an actual proof of this that you can take a look at, and also a historical note to take a look at if you'd like. I'm going to go ahead and apply it, though, in context on example 4. So let's take a look. Example 4. Find the area of the triangular region with sides 50 feet, 58 feet, and 69 feet. So we're going to go ahead and start the process, obviously, as we take a look here. So we'll go ahead and set ourselves up using S equals, or pardon, using the area equals, but S also technically in the first instance, which will equal the following. The three sides added together, A, B, and C. If you want to call them A, B, and C in context, great. You don't have to draw a picture necessarily, but it may help if you'd like to take a look. Those three sides, of course, added, then divided by 2. If you double check on the calculator, of course, ends up being 88.5. I'll continue in the context of the actual area formula as such. So the area is equal to the square root of 88.5. Again, that's S times S minus A times S minus B times S minus C. Use your calculator, of course, and when you do that, finish it with the square root, and certainly you end up then with this particular area, 1,423.54 feet squared.